Very good morning to all. Okay, so this is the fourth lecture of our subject industrial hydraulics and pneumatic. Okay, the last lecture we have started the introduction to fluid power, and in that we have discussed what is meant by fluid power. It's the basic. Then types of the fluid power system we have discussed, and in the last lecture, lastly we were discussing about the advantages and disadvantages of fluid power. Okay, so same point. Today we'll continue, and then we'll go for the next point. Okay, whether my voice is audible at your end, my video is visible at your end, and my screen, just say yes or no in the chat box so that I can go further. Okay, so you can see on the screen, I have shared the merits and demerits of the fluid power. Now, before going to the merits and demerits, that is advantages and disadvantages of fluid power, we'll take the recap on the about the fluid power system. Okay, so as we know that the fluid power systems are power transmitting assemblies or the system which are employing the pressurized liquid or a pressurized gas. If that fluid system, if it is employing the pressurized liquid, that time that system you can call it is a hydraulic system. And if it is using the pressurized gas for what purpose? To transmit the energy from a energy generating source to the energy usable area. Okay, so that time that system, fluid power system, you can call it is a pneumatic system. Okay, pressurized liquid, okay, and pressurized gas, okay, or compressed gas also you can call as it is used in the pneumatic system. Okay, so once again I am repeating, fluid power systems are power transmitting assemblies, okay, which are employing the pressurized liquid or a pressurized gas for what purpose? To transmit energy from where? From a energy generating source to energy usable area. Now, what are the energy usable areas? So especially in the cold condition, we need to transmit the energy from the energy source, that is the heat source, to the heat sink. Okay, so that transmission of energy is required. For that purpose, we are using this pressurized liquid or a pressurized gas in the power system. Getting it? So this fluid power, it is a technology, as we know that, which deals with the generation. Why I am repeating these three words: generation, control, and transmission of power using the pressurized fluid. Okay, as our subject is the industrial hydraulics and pneumatic, that means the industrial fluid power. So we should know the aim or the meaning of fluid power. For that purpose, every lecture I am repeating the same words. Okay, it is a fluid power means it is a technology which deals with the generation. One word is the generation. Please remember. The second is the controlling. Generation, control, and transmission of the power. How we are going to transmit the power? Using the pressurized liquid. In that pressurized liquid, you can take as a gas or the oil. Okay, depending on that liquid, your hydraulic and pneumatic part will be there, or pneumatic systems will be there. Okay, and one minute. I need pen. Okay, I will take. Okay, I got. Just 1 minute. See, I was talking about this one first statement, that is fluid power system. Okay, so in that, please remember this: it is a fluid power means it is a technology which deals with the generation, control, and transmission of the power using pressurized fluid. Okay, now this looking to the popularity of this fluid power system in industries. Why it is popular in industries? Because of its many advantages. Okay, and some of them are the advantages of from the many advantages. Some of them are the one is the ability to multiply the force or pressure, okay, which is possible because of the Pascal law. Okay, so here I have written that some of the why this fluid power system is popular in the industry is because of its many advantages, like ability to multiply force, okay, or the pressure. Why it is possible? Because of the Pascal's law. Then flexibility to change the direction very quickly. Then very precise movement can be possible. That can be possible using this fluid power. Again, occupies the less space as compared to the other two power transmission system or other two power transmission elements. So these are the advantages. Due to these advantages, this fluid power system is popular in industries, in many industries. Okay, so due to that only, already this part we have discussed in the last lecture, but just as a recap, I am explaining ability to multiply force or pressure. Then flexibility to change the direction very quickly. Then very precise movement can be achieved and occupies very less space. Okay, as compared to the other means what even mechanical and electrical component of the same power rating. Getting it? Now let us come to the today's main point, that is merits and demerits of the fluid power system. Okay, so in this slide I have shared the merits of the fluid power system. Okay, so quickly we will see the some of the merits of fluid power system. Okay, so first merit means what? Advantages. So first advantage of merit is that transmission of large force or the forces using a small component, meaning that is possible using the fluid power system. Transmission of large forces using small component. Okay, it is possible using the fluid power system. Now, using small component and transmission of the large forces means what? Great power intensity is possible using the fluid power system. Okay. So you will get the greater power intensity. Okay, that is possible. Then good control, regulation, and precise positioning is possible. Good control, regulation, and precise positioning is possible due to this fluid power system. Okay, because it is just a simple lever, then push buttons, electrical switches in a digital world. Okay, why this good control, regulation, precise positioning is possible? Because it uses a simple lever, then push buttons and electrical switches, etc. Okay, then next advantage merit is that startup with the heavy load. Okay, please note that here any fluid power system components are startup with the heavy load. Okay, any fluid power system component, they are startup. Okay, they can start up with heavy load. Okay, no need for self priming. That means no need to go to give the external force to start. Okay, so no need for self priming as we know that as that self priming it is required in the hydrodynamic pump. Okay, so in as we know that in hydraulics we are using the hydrostatic pump. Okay, which will start up with a heavy load. No need to worry for that. Okay, because they are our this fluid power system components are designed like that only. Okay, how it is we'll see in the next application point. Okay, why we need to go? No need of the self priming as that is required in the hydrodynamic pump. Okay, so this is the again important merit of the fluid power system. Then next one is ensure the constant force or torque. Okay, regardless of the your speed changes. That is what are the work output moves no in few centimeter per hour or the several hundred centimeters per minute. Okay, that is it is possible in linear actuator. Okay, similarly, few revolutions per hour or thousands of revolutions per minute, that is possible in the rotary actuator. So we are getting the constant force or torque. Okay, there is a no need to there is no effect of the speed changes. Okay, so constant force or torque we are getting using this our fluid power system. Okay, this point also we are again next is the merit, that is smooth operation and constant reversibility. Okay, due to the medium, as we know that in hydraulics we are using mineral oil and simple lever, so smooth operation it is possible, and again it is possible to reverse instantly. Okay, reverse instantly. Okay, so as I have told that I'm controlling the actuator very minimal medium or the very fast possible in the fluid power system. Okay, then please note that here that smooth operation and instant reversibility, that is possible in the fluid power technology. Why it is possible? Due to the medium which is used in this fluid power system and the simple levers which are used in this fluid power system. Okay, then another merit is that simple, then safe and automatic protection. So fluid power components are simple, safe and automatic production. Okay, because of the pure moving part. What are the moving parts we are using now? Then that are the what are the parts we are using in the mechanical transmission. As compared to that, in the fluid power system, in the component, what are we are using now, that are very few moving parts available. Okay, than the comparable to the mechanical and the electrical system, and many safety devices like pressure control valve, pressure relief valve, non-return valve, unloading valve, pressure reducing valve, etc. We are using in the fluid power system. Against why that all controlling devices, safety devices we are using, because to avoid the low and infinitable variable speed control. So that is possible in this fluid power. That is due to that only this is the advantage of the fluid power system. Okay, simple. This fluid power system is a simple, it is safe, and automatic protection are available. It is possible. Okay, then at last but not the least, the fluid power, the main advantage is the favorable heat dissipation. Okay, due to the nature of working fluid, what we are using now. So due to that, the nature of the working medium. So here we don't have the disadvantage that heat absorption. Okay, so here no heat absorption zone will be created. Okay, so these are the merits of this fluid power system. Okay, these are the merits of the fluid power system. Getting it? I think you have written in the last lecture this point, all points. Okay, now let us go for the demerits. Now, I will talk about the demerits of the fluid power system. Okay, so in spite of all these, whatever the we have seen the merits. So again, in spite of all these highly desirable properties of your fluid power, okay, so it is not a panacea for all power transmission problem. Okay, there is no power transmission problem. So it is not a panacea for all power transmission problems. Okay, panacea means this is not a solution for all power transmission purpose. Okay, so there is some limitations for this. Okay, it's having some demerits, so that we will see. So it has some inherent drawbacks, we can call, and that we should know, and we should note down that also. Okay, so already some R&D work, research and development activities already it started worldwide for what purpose? To combat these drawbacks. Okay, what are the drawbacks? I'm going to talk now. So about that remedies or to resolve that drawback, already development activities are started in the worldwide. Okay. Now here I have written some of the drawbacks. Okay. So first is a hydraulic oil. Okay, as we know that fluid power system are in the fluid power system, hydraulic oil are messy. That hydraulic oil is used, and that as we know that hydraulic oils are messy and that are difficult to eliminate the leakage. Okay, difficult to eliminate the leakage because in the fluid power system or component some moving parts are there. Okay, so it is difficult to eliminate that leakage. Okay, wherever moving parts are there, no, so there is chances of the leakage. Okay, and due to that, the remedy is we have to remedy on that problem is we have to use the better quality seals. And again, what are the manufacturing methods of the hydraulic or the pneumatic components are there now? So in that only we should get closer tolerance. Okay, so due to that only we can avoid this leakage problem. Okay, then second one is the pollution. So pollution of the environment because of the hydraulic oil, and some times it is due to that pollution. Okay, one is the pollution of the environment because of the hydraulic oil is used in the system, and sometimes it is that hydraulic oil it is danger for the fire attack. Okay, so these are the demerits of the drawback. Now, what remedies we should take? So we have to use the biodegradable fluid in the hydraulic system. That is the remedy. Here we are not talking only about the demerits or drawbacks. Here we are talking about the also solution. Okay. Then another drawback or the demerit is that the sensitivity to dirt.
For example, if dirt particles are entered in your hydraulic oil or in the liquid, then there is a chances of the danger. There is a danger of the wear and tear. So due to that, your system dynamics will get affected. So what will do to avoid this sensitivity to the dirt? What is the remedy? So you have to use the proper filtration design, filter design, and proper location in hydraulic circuit for our purpose to overcome this problem. Proper filter designs, and proper location. That is a remedy against this sensitivity to dirt problem. Okay. Another next fourth one. Okay, so fourth one is the damage. Okay, so that resulting from the excessive pressure. Okay, meaning lines are there. Okay, so remedy that okay, so that damage resulting from the excessive pressure. Also, to avoid this drawback, we have the remedy, that is a conditioning based monitoring that we have to apply. Okay, so we have to use will supply the energy 50 bar, 25 bar, or 10 bar, like this. That time you have to monitor all the lines, okay, using the your condition based monitoring system. So that is a solution to avoid the danger resulting from the excessive pressure. Okay, another drawback is the pressure dependence. Okay, so as we know that in the hydraulic, so hydraulic is a temperature dependent. Okay, that means there is a viscosity changes depending on the, because temperature changes, then viscosity will be changed. So this temperature depends
Hello, sir. Hello, sir.
Hello, whether my voice is audible? Hello.
Oh, voice audible, sir. It breaks more time.
Okay, okay. Okay, I got one call. Okay, so now see, I was talking about the temperature dependency. Okay, so temperature dependency. As we know that we are using the liquid or the fluid in the hydraulics. So if temperature increases, it changes the viscosity. So due to that, temperature dependency, that is the one of the drawback or the demerit of the fluid power system. Now, what is the solution of the remedy against this or on this problem? So use of biodegradable fluids. That is the solution of the remedy. Okay. Then another drawback, unfavorable efficiency factor. Okay, so unfavorable efficiency factor we have seen in the fluid power component. Okay, that is the remedy is the proper design, engineering approach. That is the solution. Okay, so I was talking about the in terms of the total system concept and the system simulation that is required. Okay, to avoid the unfavorable efficiency factor. Okay, what you will call that proper design engineering approach. So it is a concurrent approach in design of various component, okay, which is required rather than the sequential of approach in terms of the total system concept and the simulation system simulation modeling. Okay, that is essential before arriving the design parameters on the hydraulics and the pneumatic system. Okay, so these are the demerits. Okay, now let us discuss the another point, that is as our subject name is the fluid power. Industrial analysis and is the industrial fluid power. I will take. I will say like that. So we should know the brief history about that also. Okay, so let us go for that also. See. So after knowing the merits and demerits of the fluid power system, let us we will move to the on the to the next point, that is a brief history of the fluid power. Okay, how this fluid power system or fluid power it is developed. Okay, so its answer we are going to see in the this slide. Okay, how it is developed. Okay, whether it is whether this fluid power technology, whether it is new technology or whether it is old technology. Okay, that we should know. So let us we will discuss the in brief, okay, history of fluid power now. Okay, so you can see in the slide also. Actually, this fluid power is probably as old as civilization itself. Okay, this fluid power is probably as old as civilization itself. Okay, ancient historical account. Okay, actually, ancient historical account it shows that earlier in earlier days. Okay, I will highlight that. In earlier days, actually, this point I have discussed during the syllabus dictation, but as a part of chapter 1, you should know the basic. Okay, so in ancient days, water was used, okay, for or to produce the power by using or by means of the water wheels. Correct. Then air was used. Okay, air was used to turn windmills and to propel the ship also. Okay, air was used to turn windmills and the propel ship. However, these early users of the fluid power require huge quantities of the fluid. Getting it? Because of the relatively low pressure provided by the nature. Okay. That is why in the fluid power, we are going to concentrate more on the confined or the pressurized fluid rather than the open fluid. Okay. Actually, open fluid means what is the fluid we are using for our wind turbine or to turn the ship or to propel the ship. Okay, because air was used from the open environment. Okay, by the nature. What are the provided by the air provided by the nature that was earlier used for the windmills. Again, today also it is used. But the drawback or the point is that when these early users of this fluid power, no, which that for that only huge quantity of the fluid required because of the it's that relatively low pressure, okay, which are produced by the nature. Getting it? So that is why in fluid power we are concentrating more on the confined fluid rather than the open fluid. Open fluid was nature. Okay, so it's actually impetus begin with the discovery of the now how this developed that I will talk. So it's actually impetus begins with the discovery of the Pascal's law in 1650. Okay, so how that Pascal scientist, name of the scientist is the Pascal. How he discovered this law? Okay, just we will see that also. Okay. So one day, what happened? One day, the Pascal, name of the scientist, Pascal, after pouring the wine into the mug, okay, after pouring the wine into the mug, he rammed a cork, okay, down. Okay, he rammed a cork down into the bottle, okay, with a little force, steering. Then the wine bottle broken into the pieces. Okay, actually, rammed means what? He applied the force, okay, on the top of the wine, okay, in the which the wine was on the in the mug, and he rammed that cork down into the water like that, okay, like that. And after applying with a little force, okay, on the surface of that wine, the wine bottle at bottom broken into the pieces, and wine fell out, and immediately he was astronomized. Immediately he was astronomized. आश्चर्य वाटलं त्याला. Okay, see, this is a history behind this Pascal law. Okay, wine bottle broken into the pieces and wine fell out. Okay, then he was thinking, what happened to my bottle? Because as per his thinking, he applied only small force on the cork. Okay, and finally, but after applying the small force on the cork, bottle broken. He was thinking, what happened, and finally he came to the conclusion that pressure pressure generated is transmitted, okay, undiminished. Okay, pressure is transmitted undiminished in a confined body. Okay, unequal, undiminished in a confined that body of your fluid, and that pressure it acts at a right angle to your container surface. Okay, see this for example the surface of this on that he rammed cork. That means the perpendicular to this surface, right angle to the surface, confined body surface, he applied the pressure. Okay, so that pressure acts at a right angle to the container containing surface. So due to the that area difference between difference, because the small opening area at the top, okay, you can see the cork there. Sorry, wine bottle. This one. Okay, so that a small opening area at the top and the larger area at the bottom. So the bottom area acts of the greater force as it having the largest area, and hence it was broke down into the pieces. Okay, this is a simple case in which confined fluid is there in a cylinder fitted with one plunger. Okay, now I will show the another diagram. From that you will get the Pascal law. Okay, so this you can see this is a confined fluid is one of the. This is a simple case in which confined fluid is there in the cylinder, correct, which is fitted with a small plunger. This is plunger. Okay, area is, and here area is the A. Okay, area of this confined cylinder A. We are applying the force, this F. Okay, small force, that is F. Then we know that. See, we know that the pressure generated in the contacting surface, this one. What is that? P. Pressure means the P, which is equal to F by area. F by area. Okay, force divided by area. That is your pressure. Getting it? And force, as we know that it is in Newton and area is mm square. So the pressure is generated and it is transmitted undiminished and perpendicular to this wall surface. Getting it? Please note here that 1 Newton per meter square is equal to the 1 Pascal. Okay, that is 10 to the power of the okay, I think 10 to 5. Okay, means the Pascal or Newton per meter square means your 1 bar. Okay, So like this bottle was there. Okay, and he applied a small force, and due to that, that bottle break. Okay, later on, okay, so this is what are the history of the fluid power is started from that Pascal. Okay, and the conclusion is that the Pascal law. Okay, that is greater force that the bottom area on the large area, at the area was at bottom area was large, and the area that bottom area absorbed the greater force, and hence it was broken down into the pieces. Correct. Then see in 1750, okay, 60 below. 1650 नंतर आता पुन्हा 1750. Later in 1750, Bernoulli, another scientist, developed his law of conservation of energy for a fluid flowing in a pipeline. What is that? Energy can neither be created nor destroyed, but you can transfer or you can convert from one form to the another form using various devices. That was the that is law developed in or developed by the Bernoulli. Okay, in 1750. Okay, so we will see some of the popular device used for this energy conservation. Okay, as per the law of conservation of energy by Bernoulli, energy can transfer or convert from one form to the another form using various devices. Then, due to that only we should know which are the energy transmitting or the energy converting devices. Okay, that we should know. So here in the slide, I have shown the different devices and which device can transfer or can convert which energy to the on which energy. So generator, as we know that it is device, it can transfer or which will convert the mechanical energy to the electric energy. Then pump convert the mechanical energy to fluid. Please remember this is basic. This is very important. Generator convert mechanical energy to electrical. Pump convert mechanical energy to fluid energy. Then compressor converts mechanical energy to pneumatic energy. Okay. Then electric motor convert electrical energy into the mechanical energy. Then hydraulic actuator and pneumatic actuator. Okay, whatever it may be, they will convert the fluid energy into the mechanical energy. Okay. Then steam engine or ice engine. Okay, that convert thermal energy. Okay, or heat energy into the mechanical energy. So these are the devices that we should know. So Pascal law and Bernoulli's law. Okay, that operate at the heart of all this. That operate at heart of all the fluid power application, and that are used for many analysis purpose. This both law. So please remember this Pascal's law. It is a basic for our pneumatic fluid power. Okay. Okay. Now let us move for next history point. Then see fundamental that fundamental of the law of hydrostatic. Okay, that is formulated by Pascal in 1650. It took nearly 1.5 century until Joseph Bram suggested the first technical use of this discovery in the hydro. What are the law developed by the Pascal? That law technically used, okay, in the hydraulic press in 1795. Okay, and that concept is patented in that 1790. Who has developed or discovered this hydraulic press in 1795 by this. Okay, which is from actually that is totally based on the our Pascal's law. Okay, and the hydraulic was actually it is hydraulic was intensively developed and particularly in the England actually, as we should know the history. To that only I have mentioned. Okay, actually what are the development? So in England that time, all the escalator, then presses, winches, and the other power tools were driven from the public hydraulic supply. Okay, but the development lost its importance when the generation and transmission of the electric energy, which is gained okay, so that accepted toward the end of the 19th century. Okay. So after World War II, there is a boost in the development of fluid power taken place because fluid power offers excellent possibilities for the mechanization and automation of the working processes in the conjunction with the electrical or electronics. Okay, so thus it is not surprising that fluid power has exhibited a higher growth rate than the whole of the mechanical energy sector during the last decade. Okay, last few decades. Okay, so this history again. I will show some one. Let's see. This figure shows annual turnover of the sales in the West German in connection with the fluid power and the total mechanical energy sector. Okay, what are the components or systems are driven by the fluid power and the and mechanical energy sector? So it's a turnover. Okay, if you see the turnover in this diagram, this is just for your knowledge purpose. I have taken this slide. Actually, this by looking into this graph, it shows that higher turnover of the hydraulic and pneumatic component. Okay, so through this slide, I want to convey that fluid power is important. Okay, so this is a history of fluid power. Okay,
I want to show the video of our Pascal law. Okay, just wait. Because Pascal law is just a basic for our fluid. This, so we should know Pascal law. Okay, I will share my screen. Wait. Okay, through the YouTube, I will show that video. Whether voice of video was audible, audible
sir.
at your end?
No, sir.
No. Okay, 1 minute. Okay. Let it be. The related to Pascal law. Okay, I will show 1-2 video in the next lecture at the starting, and then we'll go for the main point. Okay, today we have discussed the history. Okay, about the fluid power, how it is developed in 1650, the 1750. Okay, that Pascal law, then Bernoulli's law. Okay, and how the hydraulic press. Okay, so about the hydraulic press also we'll see the one video in the next lecture. Okay. And in the next lecture, we'll start our hydraulics part. Okay. Okay. Now you can write your roll number in the chat box. Okay. And then you can leave this meeting. No problem. Thank you. Thank you very much. All are requested to write your roll number in chat box, and then you can leave this meeting. No problem. If you have written your roll number, then you can leave this meeting. Thank you. Thank you very much.